Okay, now we are in live. Greetings all. Our event will be English from this moment. This is the third panel on IEEE Özyeğin Engineering Summit. Dr. Johnson, welcome. I hope you are doing well, and we are so appreciated for accepting our invitation. It's an honor to host you in our summits. Let's start knowing you. Could you please introduce yourself a little?
Sure. I'm Randell Johnson. I had a career in power engineering and economics around power assets, and I'm the CEO of XLRX.
Thank you. How did you choose this career path when you decide to become an engineer?
It was pretty early on. I got interested in electricity, but I was curious about it, and I had early family members that were involved in electricity.
Your father?
Yes, the design of electricity systems, power systems, and it got me interested. So it's probably around, about 10 years old when I first realized that there was a power greater than some other powers that I had ever understood, and that was the electricity. That it was powerful. It was a high energy, it was high density, and it was an amazing power. Because I saw it with distribution lines like arcs or something, and I would see the energy of it, and so I got fascinated by it.
So you're familiar with electricity systems before your little age, from
Yes.
your little age.
Yes.
So why did you focus on power energy sectors? When we look at your education, you had a PhD on power engineering and master's on magnetics. Why? Why power energy sectors?
Sure. So the early those times, I got interested in electrical engineering, and I was able to understand the mathematics of it. And so because I was the early age, I had saw the energy of power, and I was fascinated by it. And then I actually I got interested in math, even though I wasn't super good at it in high school, but in college I got very interested in it, and I met some the math professors there were very interesting, in terms of all the knowledge they had. And so I started to learn that, and then I went into electrical engineering, and it connected because the mathematics, the interest in the math, there's almost a one-to-one relationship between math and electrical engineering. And it's a bunch of puzzles, it's cleverness. So I just kind of stuck with that. I quite enjoyed that.
So you are good at mathematics. That's why you choose electrical engineering.
I found
interest.
Yeah, I found it clever to study it. I found all the problems, like how Laplace connects to control systems, connects to frequency inside of power grids. I more like how all the theories interconnected together, how they all interconnect. That's what I like, to build this machine, this big electric power grid. And so I like to learn all the little theories, all the different theories around it, not necessarily to where I would focus my life on any one of the theories, but it was more how do they interconnect, so then I could apply them. I could learn how to apply them in the world.
As an electrical engineer student, I found these phenomena are really exciting and extraordinary. Do you think these steps, PhD or masters, do you think you owe these steps to become a CEO of your company, XLRX?
Oh, probably not. I actually don't attribute any degree to becoming a CEO, to be honest with you.
Not at
The
all?
no, or entrepreneurial. No, I don't attribute any degree. I attribute having knowledge so that
Mhm.
you're up to speed on certain things to certain degrees. But I don't attribute the CEO position or you know, just I don't attribute it, but it does help. The degrees help to put the knowledge together, but I wouldn't say because right, there's been a lot of CEOs that have made it. It's just basically, can you face failure and can you rise
Mhm.
from failure? Things like that. Those are things that are built into you genetically. They're not so much, you can't be taught those things necessarily. You could be made aware of them, but can you,
Mhm.
how do you suffer failure and do you rise out of failure, whatever it is, if it's a natural disaster that impacts vast amounts of people or single individual failure to your own facing, and do you rise out of it and you keep rising out of it, because it happens, right? And
Yes,
so
yeah.
you gotta
You
keep
can control
rising.
it. You
Yeah,
have to work,
the
work, work,
rise.
work.
Yeah.
There is no stop. Um, Sorry. Could you explain the responsibilities of a CEO in XLRX in a daily basis?
Well, the most of the things that I try to help to do is the thinking about what we're doing, the what are our main priorities, thinking about the next steps, 1 year from now, because a
Mhm.
lot of times everybody's dedicated and they're working really hard, but they're getting what's due, what you have to get done in a certain month. So you got to look down the field a little bit and see uh, where the whole ship is going. And so there's a lot of that, and then it's not easy to always get it right because you're trying to look into the future, and there's a lot of uncertainty. And so, in the early days when storage and clean energy was smaller, uh, I would say that we focused more tactically of how to survive. And now that the market is starting to rise and the tide is rising, all boats are rising with the tide right now in clean energy and storage. And so now it enables us to think more strategically. And so it's more like now it's evolved a little bit. Early days, it was more tactical of how you accomplish the right now objectives to get the right now obligations, met,
So you
but
had
not
a
necessarily
lot of
strategic.
rivals too.
Say again.
You have a lot of rivals too in clean energy. So you have to be strategical.
Yep.
Um, so you said the planning is really important. What are your goals in XLRX, and what are you planning to do in 5 years from now?
Yeah. So it's facilitating the world's power systems of the 21st century
Mhm.
is really what we're looking at. It's using data-driven and technical price processes to inform the grids. It's bringing forward strong analytics, deep analytics, strong operational control system monitoring and control of clean energy, and it's bringing in helping to usher in the software disruptions of artificial intelligence, blockchain, Internet of Things, just the different
IoT, right? Mhm.
technologies. Yes. And so we'll be working with that. There's plenty to do. Um, and there's many undiscovered things, actually. A lot of the textbooks that are in the universities will be outdated, in a number of things, because once you go to really highly distributed systems,
Mhm.
potentially, and with clean energy, and you take into account of the reliability of keeping systems reliable, there's a lot of engineering to do to make that happen. There's a financing to do. There's construction to do. There's design to do. You see what I'm saying? There's a lot.
There's a
There's a
lot
lot of
of
things to do
steps.
for engineers, and engineers fit into most of those boxes. And electrical engineers, obviously, along with civil engineers, mechanical engineers, some other types of engineers, artificial intelligence engineers.
These projects are really fascinating, but how did you get these investments for these projects? Because we know that clean energy can be take a lot of money rather than foils based energy.
Yes, yes. So,
Why they choosing clean energy so
well,
much?
you know, some clean energy projects are in the money with the combination of some public policy and project economics. Many clean energy projects are actually in the money. So when I talk about public policy, I'm talking about things like investment tax credits or production tax credits. And then when I'm talking about project finance, I'm talking about energy market, like energy prices, electricity markets. And we have a number of those around the world now. And in the US, as one experiment of using public policy and markets, was we were able to build economic, in that reference case, economic renewable projects. So that's been going on, and quite a bit of it. And now, you know, as prices come down, then people don't, you have less hesitancy, because there's hesitancy on price risk, that if you know the prices, if a price, the forward price curve is in backwardation, that is, the forward prices are lower than the prompt year prices for a technology, then you wait. You have what you call technology price risk hesitancy. So you wait until those price curves come down, then you start your shopping and buying the equipment. And then the only other thing is making sure that the new world needs to make sure that the renewables are reliable. You can't just say it's just only for clean energy and decarbonization. You also have to say that you still have to run sewers, you still have to run hospitals, you still have to run water systems, you still have to run trains, you still have to run cities. You can't just say that something flopping around in the wind is going to do that unless you have the engineers design the reliability into the system to actually get the job done.
It is really fascinating. So we know that energy storage and clean energy is really important, but why so important? And could you explain us the future of the clean energy?
Yeah, I just think of it as a very simple example. If you have no cash in your pocket, and I've lived pretty much most of my life like that, then when I'm in my car, if I don't have to buy gas and I could just go down the road, that would be nice. But I have to buy electricity. Now let's say there's a cost of the electricity versus the cost of the gas, and there's parity or it's less. Then there's an advantage. It's like your short-term kind of what you have in your pocket to spend in order to move forward, because you have to move to whatever. If you have to move forward to your workplace, if you have to go get food, if you have to go whatever you want to, whatever you're going to do, you know, that short-term amount of money. So if we could stop burning things, then likely that saves us money, likely. But you also have to then look at the capital costs of buying the solar and the wind and all that. And then you have to consider, you know, is by burning things, you know, the issues resulting of the environment. Any kind of burning of anything is usually not very good for any environment, right?
Yes,
it's
not sustainable.
It's not
good for our world. Too.
Yeah, possibly. Yeah, so I think so, because you know, so maybe candles. I don't know. Those are still nice, but you know, other than that, but yeah.
You didn't mention the future of the clean energy.
Oh, the future of the clean energy. It's how much does the world want to spend on it? How much can the world afford? I know that there's these ambitious goals to move towards clean energy. We've seen these kind of patterns before where you get very ambitious and all the politicians are going to start buying a lot of stuff, but then there's not the money to buy it, or there's other things, you know, or they change policies, some other threat comes forward and they have to spend the money on that. Who knows? But the bottom line is, since the costs are coming down, the costs. So the best way to solve the clean energy problem is to get the cost to come down rather than try to use policy to force it in. Get it so it's more economic with the fossil fuels. And it's been going in that direction. And then get it as reliable. And then it's a natural thing. Then everybody just kind of walks into it because it's
who
natural.
wants to buy
Yeah, if it's cheaper and it's
oil-based?
as reliable, then isn't that what grids are supposed to go towards? That's the normal regulation of a grid, least cost with minimum reliability standards. So, you know, and it's kind of, some of it's going in that direction. By 2030, we're getting very close, you know. Right now
it's
the numbers
really
are
good
looking
news
good
for everybody.
Yeah, and right now the numbers are starting to look good. So you could use public policy to accelerate clean energy, not to subsidize it so much, but to take out that price risk hesitancy. You could use some sort of incentive programs at sunset by 2030 so that the natural price drops are going to still happen. And then by the time you get to 2030, you might not need incentives anymore or these kind of things because things are more economic compared to, they're a more economic alternative as long as they're reliable. So there could be a couple of those kind of things. So I see more public policy on clean energy needed for the next 10 years at least. And then I see price curves of clean energy coming down. I see the trend of the idea of you just connect clean energy forever and you don't think about reliability of running, like what I said, sewers, water, hospitals, buildings, trams. You know, you got to think about keeping all that stuff running so that high density of people can live together.
The maintenance is
yeah,
really
and so
big.
you need so you need that, and then that, because then you're dependent on Mother Nature to handle the energy inputs, and so then artificial intelligence becomes very, very important, more important than before. And then likewise, since there's more systems that are going to go in, then the blockchain becomes quite important to help kind of connect it all and administer it.
So can we say that the most important thing in the clean energy is the price for to go further and expand?
I think it's the price.
What is the most important thing, your opinion?
Yeah, kind of. But like I said, the price is going to get, the projections of the prices by 10 years from now, 2030, they're already good now, but they're going to be really good by 2030. Then there's a lot of systems that go economic by 2030, many of them, even by 2025, many systems are starting to look very economic, more and more systems with the current. So I think what's important now is some public policy, rational public policy that's data and economic driven to accelerate that price risk hesitancy, the price risk hesitancy to basically move 2030 to now in terms of price outlook because of the incentives or the kind of things, and then let those fade out as the price curves come down. Yeah, that kind of concept. So I think it is price is very important, but I also say it's reliability too, because, you know, the bottom line is if you're 100% dependent on solar, you don't only have obligations for serving electricity when the sun is up, if you will. You know.
Yes. The next question is related with this. So, what difficulties you have encountered when you built your in the clean energy?
I think standardization has been a little bit like on the battery side, because a lot of the makers of the batteries weren't the integrators, because they were kind of going from consumer electronics to car batteries to grid scale batteries, but they weren't necessarily packaging up the whole system, you know, putting the cement down, putting the batteries on, putting them in containers, doing the whole thing. They're just making the cells, the modules, and then other people were wiring them up. And that was okay. It worked. It got the industry going, but that's now getting more and more standardized. Things like grounding that electrical engineers should be very interested in is grounding with regard to batteries is very important for the safety of batteries. And then the bottom line is they were a little costly. Even if they were manufactured, there wasn't as many projects. So it started out in frequency response, and now it's moved, and now it can be a capacity resource. Energy storage can start to become a capacity resource. And then with renewables, I mean, it's just been yields. Renewables have just improved over time. Like wind turbines are an amazing, if I was to say civil engineering and mechanical engineering, the electrical engineering isn't necessarily as amazing as, say, the aerodynamic, the mechanical, and the civil engineering. To get something that powerful to stand up and not fall over with those kind of
every
forces,
engineering area is
with
really
megawatts
important.
of forces against it. That's huge, and way up there in the air. That's a big deal. And so I'm impressed by that. But okay, so yields have gone up a little bit on both solar and wind, so that's nice. And engineering methods and material efficiencies, things like that, material design, so improvement. But the real thing is the energy storage, because because a lot of the early day renewables people were saying you could just unlimited, you can hook up as much renewables as you want. And it was kind of, I guess you could see it that way if you really liked renewables, but you also have to make sure that you engineer the system to be able to handle those. The movements of powers through distribution circuits, voltage flicker, reactive control, dynamic controls, distributed energy resource management systems, things like that, that need to be in the actual software layers to be able to manage this, because the before grids were whatever X number of things that the system operator or the utility controlled. And that X might be three numbers, 300, 400, 500, 200, whatever the number is.
Wow.
But now it's going to be Y, and that's going to be in the future, the way future, and that could be thousands upon thousands. So it's an order of magnitude change on controllability in the future. So that's where the software and automation becomes important as well in the future, is because there's just going to be more controllability, more observability, and more, because the Internet of Things makes more observability. And if you have more observability, then you can have more controllability, typically.
Yes, it's a really big area in this clean energy and renewable energy too. So in our viewers, there's a lot of people who wants to make and build their own company. What difficulties you had encounter when you build your own company, XLRX?
I think the first thing is to really challenge your own assumptions that it's going to be a wonderful journey, because typically when you build your own things, you think that they're all going to work out real great. It's going to be fabulous. It's going to go like a miracle, and it's going to be wonderful. Because a lot of times your measurements that you've had come into your brain is where you've seen functional systems working, but you haven't necessarily like functional companies that are already built and are already successful and already running. You look at that and you say, oh, I could do that. And so you say that might be true, could be true, but there's a lot of learning and a lot of work to get to those normed systems, those normalized companies that are successful and that are just running. But what you didn't see is the storming. The storming of how they got there, of all the changes and all the dynamics and everything that happened to get to that norm system. So a lot of times when we're getting ready to set up a company, we're looking at a bunch of normalized systems. Mm-hmm. But you're not setting up a normalized system. You're starting with a storming. You have nothing. You're starting with maybe cash, a computer, and a connection to the internet. And you gotta somehow create a company, and you got to go through all that storming to get to the norming. And there's a lot of learning in there. And it's not necessarily all your advisors, because a lot of times you might take on advisors from normed companies, and and that might not be as deep of advising when you need to do storming. And then you can bring on advisors from people who have spent their whole life storming, and that issue becomes they never learn how to to normalize. And so you have to sit there, and then once you start getting certain parts of your company normalized, you still are storming in other parts of the company. And that normalized piece could fall back into storming again. And you have to rebuild it for whatever reason, because you have to change the technology path, or you have to do something that you have to throw some storming back in to change it. And so I think that was the thing that I feel like is a bit underestimated. And at least it wasn't in regards to myself, because it's a big struggle to get from storming to norming.
Yes, can we say that the advisor's role in the company is a big for storming and norming?
Yes, I think so. Advisors are important, but sometimes you have to be able to kind of advisors, their knowledge and advising comes from their sets of experiences and their dynamics, but that might not be always every single piece of advising may not be appropriate for your company. I always say it this way. If somebody says, well, I like to use what's worked in the past to see if it'll work, and we kind of rely on that to what'll work in the future. Mm-hmm. I think that's true in a lot of regards. That's pretty wise. But if you have a sector changing really fast, then that may not be so true. That actually may bind you to ideas and thinking that won't let you be successful in a fastly changing sector. And right now, in clean energy and power and storage, it's fastly changing. So what we knew 20 years ago, and all that's been put into our brains, then advising, thinking that way may be appropriate for that way of thinking and for that sector of that time. But is the future sector 10 years from now, is there a new normal that's coming to us in terms of automation, software, digitization overall?
Yeah, I'm agreeing with this. You have to be open-minded for the future also. So when we look at your company, what do you care most in your management styles about your employees?
I think it's just respect is the main thing. It's just always finding respect. So if you're as you're going through storming, not everything's going to be perfect in the storming phase, nor in the norming phase, to be fair. And so you have to guide the main principles of respect and trust is what you really have to follow, even if every single moment sometimes it's difficult. You still have to, it's like a mean reversion. You have to revert back to the average, and the average is trust and respect. I mean, that's the only way I can work, in terms of understanding, because you change, you start 1 year or 6 months, and then your company can change 2, 3, 4, 5 times as you go. And so you have to go back to first principles in order to work with people. And so, that's why we just kind of keep reverting back to trust and respect. Yeah.
Respect has to be default.
Well, and not necessarily default. It has to be earned.
No,
right?
Yes, that's what I mean.
For respect, you do respectful things, and people respect you for that. You solve an interesting problem, and people find that fascinating. You write an interesting article, and people read it. You draw an interesting diagram, and people look at it, or they ask you questions about it. So that's just doing things, just you manufacturing something that somebody else then looks at and says, oh, a concept has been transferred, an idea has been transferred, and they like it. You've impacted them. You've put a piece of knowledge in their mind.
You put your work into it, right? So let's go to the COVID-19. How you manage the pandemic situation and what changed in your business life?
Yeah, so the pandemic, um, you know, the it got focus went up. There was less distractions going on during the pandemic. Less just different things going on because there was less driving down the road, less going into office, less traveling on airplanes. So you didn't have to deal with all those things. And if you add all those things up in your life, they add up to a big part of your life. And so for us, the pandemic resulted in um, just, I think people were able to focus more, to be fair. I found um, deeper, I found just a lot of interesting contributions during COVID. I found people reading more, and learning more. I felt like it, but it could be, and then learning how to then interact with people on the mediums of the video conferencing and conversations. So it's just learning to change to where from shaking hands and hugging to just waving on a like a Zoom meeting or something, that kind of thing. So just a little different.
Yes.
We just been working. A lot of it was for us. We're a technology business, so a lot of it was, we didn't have we didn't have a requirement to be in any one specific building because we had virtualized very early on. I throw a thought-provoking idea out is we had already achieved the company. We had already gotten to the level that we no longer needed to even use emails in our company. So we've gotten totally out of emails because emails are this big fragmentation of information, breakdown of communication, all this kind of stuff. So we were able to we were already off of emails by COVID. So we already had a new communication structure off of emails for internal communications, emails externally, of course. But we had already developed communication structures that are more conducive to work from home, that are more facilitating to work from home.
Yes.
Or work from wherever. It didn't have to be home. Some people were working from wherever. It didn't matter. It became
doesn't matter. Yes.
It didn't matter. We had already had all the systems, so you can see, you could you can measure. There's not a problem, and you can prioritize. It's not a problem with digital systems. So it didn't necessarily need to be in an office kind of thing.
So we can say that your team's efficiency, your company's efficiency raised in the pandemic situation.
I think it felt like it, but I think our focus improved, and that focus then increased the efficiency.
Mm-hmm.
Yeah.
So let's look at the clean energy one more time. How would you evaluate the countries in regards to adapting to clean energy? And which energy markets do you think are the right path for adapting clean energy?
I just think overall the solar plus batteries, those two together offer a lot to the world. So just that area offers a lot, and that area right there already needs all kinds of electrical engineering services in order to get it done, from valuing it to planning it to designing it and to operating it. So just solar plus batteries. Wind is important. It's going to be really important, especially coastal wind. That has a lot of value.
Coastal wind.
Coastal wind, wind that's put offshore along coasts. Those are where you can get up into the tens of gigawatts of energy. That's kind of out of sight, out of mind a little bit. and then the disruptions, you know, of the automation and the software, and then the markets, the evolution of the markets, and then the evolution of the public policy. I mean, we need kind of, so clean energy is, yes, about a couple technologies, and then obviously the bi-directional vehicle to grid, you know, to where you can send energy both ways, and solar plus batteries. You know, that right there is a lot to handle. That's massive. There's literally, you know, if you add them all up, the individual systems, you're millions and millions across the world. So that's already, you know, kind of in a good. And you know, and there's use cases for electric bikes and things like that, that more and more use cases for them. So I just think just the electric vehicle, the solar, the battery, some wind, more, you know, different kinds of other kind of develop. I do think there's room for it. You still need energy sometimes distributed. So you may need hydrogen in fuel cells to create, you know, if you do need to produce energy, and a lot of it, high density energy at a node, then, you know, you still need those systems. And then nuclear has a role. I think and even fossil fuel, while, you know, right now the trend is to say that the whole world's going to go to fossil fuel, and I mean, renewables. The bottom line is the fossil fuel is here. It's going to likely be here for a long time to come. It's going to be, you can think of it as, yes, it could be government regulations that get it out, but often markets move it faster. So if you bring down the prices for competing technology, that usually moves out old technology the fastest. Governments can try, but it's usually just market forces that push things out faster than, like the kerosene lamp versus the electrical, the light bulb, you know, a kerosene lamp versus the light bulb. You know, it was obvious. You didn't need a huge amount of public policy to get that done. But still, setting goals in research and development and innovation in clean energy so that you can keep getting the prices down, that's good. So that's kind of where and I guess any one of the countries, you know, will do various forms of it. But we always say, you know, don't throw caution to the wind, because, you know, disruptions in costs in electricity systems could, you know, there's correlation disruption in political systems, you know, because it hits so many people.
Yes, you know, it affects everybody.
Millions of ratepayers or millions of voters. So it's kind of like one of those things that you have to work your way through and make sure institutionally that transformation can be done with least risk. You know, and that's cost risk, that's reliability risk. That's just you just want to de-risk it. And it's kind of like the world already has this knowledge of how to do it. It's just a question if it's going to do it or not, you know, because it's easy to just buy clean energy without buying reliability. It costs more to buy the reliability. So it'll be up to each country's destiny is how much they want to, you know, how fast they want to transition, if they're going to do that, and which technologies they're going to choose in that transition, and what levels of reliability and resiliency they're going to choose in that transition. Because obviously it's cheaper to not have any reliability, right? That the electricity can just go off anytime. That's cheaper. It's a cheaper option, but
not wiser.
It might not be. In some cases it might be okay, but in many cases it's not okay. It's not as good as to what the fossil fuel is providing right now.
Yes, you're right. So what do you think about the importance of multi-agent system perspective or simulations for smart grids or energy markets in general? How would you define the future of autonomous systems on behalf for your company?
I think there's this idea, like I said, it's going to be an order of magnitude or more of dispatchable and controllable systems, from centralized systems to distributed systems. You go up an order of magnitude or more, maybe even 2 orders of magnitude of the amount of controllability, like virtual power plants. And so you will need autonomous kind of control at nodes, but autonomous control at nodes can be less effective, and you may end up spending more on a power grid than if those autonomous controls are coordinated through virtual power plants. So you're going to need what I call the middleware, the layer of control that is between the settlement of the physical and financial transactions and the edge of the local universal energy management systems on the edge that are more or less autonomous, but still get information from outside through the middleware, because things like weather forecasts that are done by supercomputers won't be done at the edge. And so in order to predict solar and then decide on how to charge or discharge batteries, having knowledge of the weather is important, and the edge control won't be able to create that knowledge, all of it. It'll be able to add some to that knowledge, maybe through sky-facing cameras or through local measurements, but the forward knowledge is being done effectively in the cloud with much bigger computing power. So there's going to have to be this interplay of coordinating these autonomous. So I'm not into this world that'll be 100% autonomous. There'll be a lot of autonomy. There's no doubt about that. But once you can just play with it in your mind a little bit. Take a city that has no distributed energy resource. When I talk about distributed energy resource, let's talk about just a small microgrid, a car charger, solar panels on the roof, batteries at the house, an EV, a bidirectional EV, a load, and a grid connection. So, 6 things in that grid, and various things can be available and not available. You could do demand response, and you could have control. There's moments that if you then had 50 or 100,000 of those in a city, they could be aggregated together voluntarily and through tariff for payment for compensation, but voluntary, but digitally, so that you don't have to overbuild the power grid. Because if you can't depend on all those autonomous systems, sometimes for social good, for maximizing social welfare, then you could end up overinvesting in the system. And so all these distributed systems, if we can have voluntary and tariff kind of access to them, to be able to use them dynamically, then when the grid is in trouble, the wider grid is in trouble for whatever reason, through a weather event or through some sort of other kinds of events, like human caused events or weather caused events to the grid, then the grid can kind of switch itself around, could maybe do a little more self-healing, can do a little bit more of targeting and driving resources to places of need, such as hospitals, such as kind of relief centers, local like news agents, where you can get fresh water or you can buy different things. Secondary critical infrastructure that becomes primary critical infrastructure when there's human or weather caused events.
Thank you for answering. There are a lot of Turkish people who dreams at work at tech companies like yours in energy area. For instance, if a Turkish graduate or intern applies to a position in your team, what requirements would you expect from him or her? You can split answer it into 2 parts, internship or full-time.
Well, it's not something that you can just really put a very precise metric on.
Mhm.
It's more like if there'll be like whatever skills we need at the time, whatever we're working on, because as we're building through the tech stack and different things that we do, our required skills move of what we need. And so, our view is just be true to yourself. There's temptation to, in universities sometimes to, let's say, use information that you didn't create in order to add to your success. And so we would suggest, being true to yourself. And while you may have access to that information that you didn't create that adds to your success, make sure you're doing things that actually add to your success, individually created, original works. Because the amount of intellectual integrity that's needed for what we do, and also there's a little bit of passion as well. That's a demonstrated passion of how deep is the interest into whatever subject it is. It could be that you have a very deep interest in one of the particular fields within the university, and you have a deep interest in there, and that deep interest could be reapplied in a commercial way, in a very nice way. So the passion is there, and all it is getting an application of that passion. Because in my mind, learning is partially and should be, or is a lot tied to your own passions of what you want to learn. A lot of times, sometimes, maybe there's not as much choices, but it's like, are you interested in what you're doing? And that kind of shows up on your contributions in that area, whatever area is your interest. So we kind of look for that. Is there some strength and conviction towards the subjects that people are studying, and the general just candor of do you
Passionate or not?
Yeah, do you really like what it is you're doing, kind of thing. Yeah.
Yes, I believe that too, because when you have a passion for something, the work is not like work. It's like having fun, or it's much tolerable for other things.
Yeah, it's intellectual curiosity. Do you keep digging deeper and deeper into an area that you're interested in, and your intellectual curiosity is turned on such that it's automatically recognizing that you've learned something new. Something new has come to you because you've already learned 10 or 15 things in an area because of what you've been interested in, and you're getting wise enough to figure out that, oh, this is actually something new. This is a new idea that I hadn't been aware of, and it fits in this way. So it's that kind of intellectual curiosity of the new things too, that you realize that you're consciously saying, hey, this is actually a new piece of information. This is a new idea, a new method that I hadn't been aware of. And that fits into my overall set of methods that I've learned in my life. Yeah.
So in the hiring process, what is the most important thing? You said you passion, but do you look at the GPA or self-development more? Which one?
You know, a lot of these GPAs I have found aren't very accurate because there's a lot of people that are walking around with 5 and 10 years of exams and homework assignments for pretty much most of the professors. So to come out with a perfect score might just mean you had perfect information. You had all the information, you knew the game, and you knew how to play the game. It doesn't necessarily mean that you were a star student necessarily, not in all cases. Also, there's areas of character. There's areas of what did you do? How did you get to where you've got? What's your a little bit of your story of how did you assemble yourself in terms of your pursuit of knowledge, your pursuit of the skills, the pursuit of the things that you show on your resume, you know, the strength of that and the conviction of that, of how you pursued those objectives. Those are kind of important to see. And then obviously accomplishments and things like that are always good to see. The world doesn't necessarily only depend on what you have on paper though, because a lot of times what you might think is good to put on paper it might be good, but there might be other things that an entity like a company is doing that you may not be able to find on Google, or you may not be able to find in other locations. So just running down the typical, oh, I got to have this on my resume, and I got to have this, and I got to have this, and I got to have this, and that should pass the test. There's a little bit of the reality of it is there's usually quite a bit more going on inside of companies than what might not meet the eye in terms of you know, what you've learned in terms of the academic, and then translating that to then university without, or to industry without having been in industry. So a little bit of open-mindedness and understanding that there's that learning only commences at the end of your degree. It doesn't stop. It commences, it starts actually. And if it stops, it can, I mean, you can have a life like that, I guess, but it's really the start of it, to be fair, the real start in my mind, but yeah.
Thank you. As a CEO of energy storage and clean energy company XLRX, today are some highly popular topics like data science, artificial intelligence, and more areas. Which area do you think will be most valuable and most wanted in the near future?
That's interesting. You know, I go back to, I start with capital flow. And I ask the question, where is the money going to flow? And then if you subscribe to a future of clean energy and a lot of clean energy investments, then start breaking that down. Okay, so if money is going to flow to clean energy investments, then that means they've got to buy some things. That means they've got to make some things, then buy some things, then build some things, and then operate some things, right? And lots of it. Mm-hmm. And so then you sit there and you watch that down that path and you say, what set of skills optimizes me across that whole path, that whole frontier? And because, right, there's making of goods, there's then the design, the planning, the valuation, and then the engineering of all that. And there's a lot of engineering all through there, and a lot of electrical engineering. And so the way I've always assessed what skills I should be in is, first and foremost, the ones I want to be in. Secondly, where's the money? Where is the flow of money? And how is that pattern of flow of money going to go? If you're going to say research, let's say kerosene lamps right now, and want to get a career in kind of that, maybe there's a role for you, but maybe it's not a role for millions of people right now. You know, so it's looking at where is society moving, where is society going to spend the money, and that's where society is going to need the engineers to actually engineer the systems, because just spending the money alone isn't necessarily going to do the job. You need the engineers to then go make the systems.
Yeah, that's the truth of the life. You need money, that's for sure, for everybody. Yeah, because you have to survive.
So it's watching the capital flows, and right now, a lot of capital flow on solar, a lot of capital flow on batteries. So clearly,
which area?
solar and batteries, and then anything associated with that, right? There'd be the valuation of them, the planning of them, the design of them, the operation of them. It could be electrical engineering, like doing one-line diagrams. It could be engineering the substations. It could be doing artificial intelligence. It could be a lot of field work, building them, actually putting them together and monitoring. It could be the grounding systems. It could be the study of them. You know, all these things over the next 10 to 15, 20 years, that it could be just the development of them. All you do is it could be the financing, where you go into financial sector and look at it from a financial point of view, and doing project financing, and then doing assessments. There's engineers that are there. So it's, so that's why I say that, you know, I just watch the capital flows and where money is being spent, or by governments and by, you know, where the big development banks and investment banks are saying that money is going to be spent. And like Bloomberg and things like that, listen to those folks, and then design, and then start thinking about your engineering skills and what you've learned as an engineer, and then start mapping it into each element of that supply chain of where you could find work and add value, make contributions, and then obviously bias to your own interests.
Okay, thank you very much. If you were a student again, would you choose to be an engineer again and specialize with power energy, or would you just pick some random thing?
Yeah, it's hard to tell, because I only get one shot at life, as far as I know. And so it's been good. Engineer's been good so far. It's good field.
So you don't have any regret for choosing?
No, I've enjoyed engineering systems, and I like design, and I like valuing, and I like planning, and I kind of like it. I like the philosophy of it, but maybe I'm a lifer, you know, maybe that's just because I did it my whole life, and so I like it. But, you know, I liked it early on, so yeah. So
you're the perfect fit for this
I don't know if I'm the perfect fit, but I do find it, I don't have any, there's plenty to do. All I'm saying, well, I guess let's put it this way: with clean energy investments and with everything, like if you're on the power side and you want to go into power and energy, because there's other sectors you can go into as well with the IEEE, many of them. But if you're on the power and energy side of things, for us, there's been a lot of change over the last 20 years. So that's made it interesting. It hasn't been a static business. It's been under evolution for a good 20, 30 years now. And it's in this latest round of evolution with the clean energy and resource change, looks like it's going to be pretty, you know, a lot of engineering, a lot of valuation, a lot of planning, a lot of design is going to be needed. And that flows into a lot of other things like the IoT, the software. It flows into even devices, you know, like hardware, computers, things like that.
So we have short in time. I have one last question. What would you recommend to younger students which wants to be a CEO as an engineer, like you?
Yeah, I would just be true to yourself. Just be true to yourself. So, like I said, if you get a hold of this information that's advantageous to you, but it's not an original production, but it helps you get higher scores on exams, remember that if you're not learning that material, then you're just going against yourself at the end of the day. So the thing is being true to yourself, continue to acquire knowledge, continue to assemble and patternize that knowledge, how it all fits together, continue to network, continue to, because that's what we have to do every day. Is just a small little principle. Is just if every day you learn something new or you do something new, then you just keep adding to your knowledge, and you add to your strengths. And then when you get into, if your goal is to be in the workplace or in industry, then you've built up a set of skills and a knowledge so that you can compete with others who are doing that. And because it is a lifetime competition, if you will, to stay relevant, to stay and to avoid being complacent.
Thank you for answering our question. Our time is up. Thank you so much for coming to our summit, our invitation, and accepting our invitation. It was an honor and pleasure to hear you and moderate this event. Thank you so much.
Thank you. It's an honor as well. Thank you.
See you